in mathematics mean? What's the word quotient mean? Division. So yesterday we did the power rule and the product rule. So product is multiplication. So I did the multiplication rule. So today we're going to do the division rule, which is like the rule for fractions of functions. So we're going to have like function f divided by function g. So the quotient rule says that if you have f divided by g, then the derivative is equal to g times f prime minus f times g prime all over g squared. It's the derivative of the numerator times the denominator minus the numerator times derivative of the denominator all over denominator squared. That will play in your head as you're doing this. So it's very similar to the product rule, except for there's subtracting and it's reversed. Exactly. Because of the proof. There was a proof. So I tend to teach a trick for this. So we have f over g, and we're going to call that the high over the low. So it's hi ho, it's off to class you go. So you can say ho d high, where the d stands for the derivative. So ho d high minus hi d ho all over ho ho. So hi ho, it's off to class you go. Ho d high minus hi d ho all over ho ho. Yeah, like high is the upper function, or high like is in a higher function, f of x. And ho is the lower function because it's down low. So hi ho, it's off to class you go. Ho d high minus hi d ho all over ho ho. Ho d high minus hi d ho all over ho ho. I'm not very musical. All right, so the directions are going to look like this. Find f prime of x given f of x equals x squared minus 1 over x squared plus 2. Yes, the numerator is a difference of squares, but the denominator is a sum of squares. You cannot factor and simplify, so there's no way to clean this up algebraically. So we are going to do the quotient rule. So you have hi ho. So f prime of x equals ho, which is x squared plus 1, d high minus high d ho all over the denominator squared. So at this point, we're going to distribute and clean up. The number one mistake students make is losing and distributing the negative. What? So it becomes 2x cubed plus 2x. If you distribute that negative, you get negative 2x cubed plus 2x all over x squared plus 1 squared. 2x cubed and negative 2x cubed cancel. And we get 4x over x squared plus 1 squared. So it's not terribly difficult. That's it, you're done. So here's the thing, like if I ask you now, if I said, okay, find f prime of 4, is a FOIL denominator going to be easier than a factored denominator to plug in 4? Right, so that's why we don't FOIL it. So like, because if I asked you to find f prime of 4, you'd just be like, okay, 4 over 4, and then 4 squared plus 1 squared. So it's definitely easier to do 4 squared plus 1 squared versus 4 to the 4th, which is what would happen if you FOILed the denominator. Exactly. And if I asked you to find the second derivative, then you would have to FOIL until we have a rule for a function to a power. But at this point, we're not going to find higher order derivatives of something like this. We will eventually, but we have to learn another rule called the chain rule first. What? All right, so let's do the quotient rule. F prime of x equals ho d high minus high d ho all over ho ho. And again, I cannot stress how that negative is going to distribute to everything over here. So to clean it up, we do have to FOIL the numerators out. So x cubed times 2x is 2x to the 4th. 2x times 6 is 12x. 1 times x cubed is x cubed. And 1 times 6 is 6. Now you can either distribute everything and then take in the negative, or you can distribute the negative while you multiply. It just depends on how confident you are in your algebra. So that's like a negative 3 times x squared. So you get negative 3x to the 4th. Negative 3 times x gives negative 3x cubed. And that negative times the negative with the 3 and the 2 become positive 6x squared. All over x cubed plus 6 quantity squared. So we have 2x to the fourth and negative 3x to the fourth. We have x cubed and negative 3x cubed. And then they have x squared, x, and a number. So we only have two like terms. So we get negative x to the fourth minus 2x cubed plus 6x squared plus 12x plus 6. And we are done. Yeah. It doesn't get any more difficult. Never. So yesterday we talked a lot about square roots and how in order to do a square root, you need to rewrite it as a fraction, right? So this is x minus 3x times x to the 1/2 over x to the 1/2. So x times x to the 1/2 becomes x minus 3 x to the 3/2. Are we okay with that? Because it's 1 plus 1/2, so you get 3/2. So denominator times derivative of the numerator minus the numerator times derivative of the denominator all over denominator squared. Cleaning up, you get x to the 1/2 minus 9/2 x, because 1/2 plus 1/2 is 1. Minus 1/2 x times x to the negative 1/2 is like 1 minus 1/2, so you get a 1/2. Minus a minus is a positive 3/2, and x to the 3/2 minus 1/2 is x. And what's a 1/2 squared? It's just x. So grouping together my like terms, one minus a 1/2 is a 1/2. And negative 9/2 plus 3/2 is negative 6/2. A negative 6 divided by 2. So you get negative 3x all over x. And technically you could take that x and split it up. So you get 1 over 2 square roots of x minus 3, if that, helps you see things a little bit too. Now, yesterday we talked about how there are times where it is more helpful to FOIL than derive. Well, there are times in calculus where it is more helpful not to use the product rule and to use common knowledge of algebra. So if you go back to the original f of x, what could I have done algebraically with the original f of x to get rid of the quotient rule? In mathematics, if your denominator is a single monomial term, you can rewrite that denominator under all terms of the numerator and simplify. So as long as your denominator contains no addition or subtraction, then you can divide the top terms by the bottom terms. So x over x to the 1/2 became x to the 1/2, and 3/2 over x to the 1/2 became negative 3/2 x. So now the derivative is 1/2 x to the negative 1/2 minus, oops, sorry, I added a 2 here that wasn't there. Which is exactly what I got over here, but involved a lot more algebra. Yes. So this right here is 3x times square root x. So then here it became 3x times x to the 1/2 because I rewrote the square roots as 1/2 powers. And x, which is to the first power, times x to the 1/2. Well, the rule is that you add powers when you multiply them. So it became 3x to the 3/2 because we had to add the 1 and the 1/2 together. Okay, process through. I'm in no rush. Are you okay now? Do you kind of see what I did? Okay. Are you looking at the next page of notes? Oh my gosh, Colby. Oh, because I made you do the first like product rule in your notebook. What do you think is hard? Which next one are you talking about? Oh, when he said, does it get any harder? And I was like laughing too. All right. So then as an add-on to that question, it's find the equation of the tangent line to the point. So it's really important to remember that the equation of the tangent line in calculus is y minus y1 equals the slope of the tan, x minus x1, where the slope of the tan is simply f prime at x1. So now we know how to find derivatives without using the limit. So we kept saying the slope of the tangent was equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Well, that's the definition of the derivative. Now we know how to find derivatives. So the slope of the tangent is equal to the derivative at x1. So in the case of the previous problem, f prime of x was equal to 1 over 2 square roots of x minus 3. So in this case, the slope of the tangent is f prime of 1. Because the point is 1 comma negative 2. So the derivative is f prime of 1, which is 1 over 2 square roots of 1 minus 3, which is 1/2 minus 3, which is 2.5. However, we want to keep that as a fraction, so we'd write it as negative 5 over 2. Yes. Because it gave you the point 1, negative 2. So that makes 1 your x1. And whatever your x1 is where you're finding the tangent slope at. Because the slope of the tangent line is going to change for any point. So if I pick the point 2, the slope of the tangent is going to change at 2. So the equation of the tangent line is y plus 2 equals negative 5/2 x minus 1. And again, that negative 2 came from plugging in 1 to the original. So if they didn't give you the y value, it would have been f of 1 plugged into that original function x minus 3x square root x all over square root x. So like if I said find the equation of the tangent line at x equals 4, then you would have to find f of 4 and f prime of 4. So f of 4 would have been like the square root of 4 minus 3 times 4. So 2 minus 12 or negative 10. And f prime of 4 would be 1 over 2 square roots of 4 minus 3, or 1/2 times 2, so 1/4 minus 3. So you get negative 11/4. So your equation would be y plus 10 equals negative 11/4 x minus 4. So you could find the equation of the tangent line at any point once you know f prime of x and you have your original function. Does that make sense? I think for our one quiz, we were struggling to find the equation of the tangent line because we didn't know how to find the y value here. Yes, I was like, not the one I took Monday, but like before that one. Yes. Hey, look, I'll add you in as making sure math keeps coming in a full circle. It's okay. That's why I'm trying to still create clarity. All right, so the rules are super important. And in math, sometimes you don't have a function, you just have values. So again, on that last quiz, I gave you an intermediate value where like you had the originals and you had the derivatives at 2 particular points. So here we have the originals and the derivatives at particular points. And we're just going to apply our product and quotient rules to find the values that we're looking for. So we want to know what's the derivative value of function f times g at 5. So if you think about it, and again, you don't have to write down the first part, but if this was in general, then that's the product rule. It's the first times derivative of the second plus the second times derivative of the first. But now, instead of at x, we're talking about at 5. So it's f times g prime at 5. So you get f of 5 times g prime of 5 plus g of 5 times f prime at 5. And then you're just going to use the given points to find the solution. So f of 5 is 1, g prime of 5 is 2, plus g of 5, which is negative 3, times f prime of 5, which is 6. So you get 2 minus 18, or negative 16. So similarly in B and C, we're going to compare F divides G to G divides F. So ho, di minus hi, do, all over ho. So it's g of 5 times f prime 5 minus f of 5 times g prime 5 all over g of 5 squared. So that's negative 3 times 6 minus 1 times 2 all over negative 3 squared. So you get negative 18 minus 2 over 9, or negative 20 ninths. So f divides g prime of 5 equals negative 20 over 9. Let's find g of f prime of 5. So it's ho di minus hi do all over ho-ho. So 1 times 2 minus -3 times 6 all over 1 squared so we get 2 plus 18 over 1 or 20. What? I don't know though, I like it. It's hard. It's just something you have to memorize still.